Hi everyone, we've got a tricky vectors question here, and it's year 13 vectors because it's in 3 dimensions. Relative to a fixed origin O, a point A has position vector 4i minus 3j add 5k. The point B has position vector 4j add 6k, and the point C has position vector minus 16i add pj plus 10k, where p is a constant. Given that A, B and C lie on a straight line, find the value of p. Okay, first of all, let's get some kind of a sketch representing the situation. Okay, so we have 3 points, A, B, and C, which lie on a straight line. So there's our A, there's our B, there's our C, and here's our origin. Okay, so there's our 3 points on the line, like so. Now we've got to find the value of P. So I think that what we're going to need to use is, let's think about the fact that if I wanted to go from A to C, then if A, B, and C lie on a straight line, then to go from A to C is some scalar multiple of going from A to B. Okay, so if I now write some expressions for A to C and A to B, then hopefully we can get some equations that will enable us to find out what P is. So first of all, let's write down an equation for how do I go from A to C. Well, to go from A to C, I need to do minus A add C, which is the same as C minus A. Okay, so that is going to be C minus A, so that is going to be minus 16 P and 10, and we're going to subtract from that A, which is going to be 4 minus 3 and 5. Okay, so therefore our vector going from A to C is going to be minus 20, and it's going to be P add 3, P add 3, and it's going to be 5. Okay, so that's our vector representing A to C. Now let's look at the vector representing A to B. So A to B, as you can imagine, is going to go from, I'm going to do minus A add B, so it's going to be B minus A, which is going to be 0, 4, and 6, and we're going to take away A, and A is going to be, again, 4 minus 3 and 5, like so. So we take that away, and for this one we're going to get minus 4, and we're going to get 7, and we're going to get 1. So that's our vector A to B. So we're going to basically say, remember we've said that to go from A to C is some multiple of A to B. Okay, so let's look at a line that we can compare. So basically here, this top line and this line here, we've got that in our A to C, we have got minus 20, okay, and in our top line here, we have got minus 4, and it's going to be times by lambda. So that's implying that the value of lambda is going to be 5, okay. So our lambda is actually equal to 5. So what we've done is found expressions from A to C, found expressions from A to B, and use that in order to work out what the scalar multiple is to kind of like, being as they're parallel, they've got to be scalar multiples of each other. So now that we know that lambda is equal to 5, what we can do is we can now use that in order to work out what our value of P is. Because we're going to say that here, if we've got to do 5 times A to B to get to A to C, then that means that looking at this line here, we're going to need to do 5 times by 7. Okay, 5 times by 7. So 5 times by 7 is going to equal P add 3. 5 times 7 is going to equal P add 3. So 5 times 7 is 35. So therefore we're going to have 35 is equal to P add 3. So therefore P is equal to 32. Okay, so that's our answer for part A. That P is 32. Okay, now let's have a look at part B. It says the line segment O to B is extended to a point D such that C to D is parallel to O to A. Find out what the length of O to D is, writing your answer fully as a simplified surd. Personally, I think this is quite tricky myself. I'm not a big fan of this, but let's have a look and see what they're indicating. So we've got here our A, our B, and our C. Okay, so there's our A, there's our B, and there's our C, relative to some fixed point O. Now, what they're saying is that this is extended, okay, in such a way, so it says OB is extended to a point D here. Okay, so this is our origin there. Okay, so OB has been extended in such a way that C to D, in other words, this line here, C to D, is parallel to O to A. So that's kind of what they're saying there, if we imagine that's A there. Okay, so basically this line has been extended all the way out to some point here, D, such that these are parallel. That, I believe, is the essence of what they're saying. And we've got to find out the magnitude, in other words, the length of O to D. We want to find out this length here. So let's have a think about this. What can we say? Well, we can say that if they're parallel, we can say that going from C to D is going to be some kind of scalar multiple of O to A. Because if these two are parallel, then C to D is some fraction of O to A. So we can certainly say that. And then let's write an expression now for going from O to D. So to go from O to D, I'm going to need to go from O to C. So I would do from O to C, which we can find. We've got the position vector for that, actually. And then I would need to say plus C to D. Okay. So therefore, that's my expression to go from O to D. It is O to C plus C to D. Okay, so let's think, what is my O to C? O to C were given in the question. That is, O to C is minus 16. Remember, we now know that P is 32 from part A, and the final value is 10. So that's my O to C. Now, C to D is some fraction mu of A, and A is 4 minus 3/5. So we're going to do some scalar multiple of what A is, and A is 4 minus 3/5. Okay, so that's my expression for my O to D. So far, so good. Okay, so far, so good. Now, let's have a think about the next bit. What else can we say about O to D? O to D is some kind of a scalar. We can also say that going from O to D is also some kind of a multiple of O to B. Okay, so I'm going to give that a different variable. I'm going to say that that is lambda of O to B, which is 0, 4, 6. Okay, so that's another way of writing what O to D is. So O to D is some fraction of O to B because it's O to B extended. So I've put lambda there like that. So I'm going to bring these two results together now, and I'm going to say O to D is therefore lambda 0, 4, 6, and that is equal to minus 16, 32, 10, plus mu times by 4 minus 3, 5, like that. Okay, and that's the crux of what we've got there. Okay, so from this, let's see what we can say. Ooh, we can find out what mu is from the top line here, because our top line of this equation is going to say that 0 is equal to minus 16 plus 4 mu. Okay, so therefore 4 mu is equal to 16, so therefore mu is equal to 4. Okay, so we found out that mu is equal to 4 from that top line. Okay, now once we know that mu is 4, we can find out what lambda is. So let's just pick any one of the other equations. Let's just pick 4 lambda is equal to 32 add minus 3 times by mu. So we're going to use the second line now. So I'm going to say that 4 lambda is equal to 32 minus 3 mu. Okay, so therefore 4 times by lambda equals 32 minus 3 times by 4. Which is going to be minus 12. So that's going to give me the fact that lambda is equal to 5 when I solve that. So I've now worked out what my mu and my lambda are. Okay, so I can sub those in now to my expression for O to D. So my O to D, I don't really need the lambda, but here in my O to D expression, now I know that mu is 4, I can sub that result in. So let's sub in that result there, that mu is 4 in O to D. So O to D is now minus 16, 32, and 10, plus 4 times by 4 minus 3, 5, like so. okay, which means that O to D turns out to be minus 16 add 16, which is 0, and 32 take away 12, which is 20, and 10 add 20, which is 30. Okay, so that's what our O to D is. So therefore, our magnitude of O to D, is going to equal nothing squared add 20 squared add 30 squared, and that whole thing square rooted. Okay, so therefore O to D, when we work that out, turns out to be 10 root 13. So 10 root 13 is that's a 10, not a 6. So 10 root 13. And that's our answer for that one. Personally, I thought that was tricky. I thought that was definitely tricky. So let's just kind of review what we did. We basically found, we had to try and find the length here. Okay, so we found an expression for going from O to D, and we found out that going from O to D, essentially we used the vector method. We basically just used the vector method and we found two different routes, essentially, to go from O to D. And we found that one route was to go along here and up here, and another route was to go directly up here. Okay, but the route of going along here and up here, it basically, we had to use, what was a little bit different is the way that we had to use that going up here was some multiple of doing that. That was a little bit unusual, okay, and not something that we've commonly sort of seen before. Okay, so yeah, so there we go. That's what we did. We found two different routes going from there to there. One was that way and one was that way. We equated those two routes because they were equivalent, and then we solved for our unknowns, and once we did that, we were then able to find our magnitude. Perfect. Excuse me. I hope you found that helpful. Remember, you know what I'm going to say. If you're finding these videos helpful, do remember to like and subscribe to the channel so that I can keep on producing videos. Honestly, it makes more of a difference than you know. So I'd really appreciate it if you could. That would be perfect, because I think the vast majority of people who watch don't subscribe, you know. So it'd be great if you were able to subscribe. That'd be much appreciated. And thank you for watching, and I'll see you in the next video.